Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime podcast. We've got a great guest today. Dainis Kruze is here from Aerones. Alan, what were some of your takeaways from our call with Dainis?
Well, Dainis is bringing his robot technology. It's not drone technology. It's sort of a tethered robot technology to the world to do a variety of tasks that were typically done with people on ropes, from measuring the lightning protection system, resistance measurements, to cleaning out drain holes, to repairing leading edges and detecting structural issues with blades. His robotic platform and our own robotic platform is doing astounding things and very quickly and efficiently. So it's just like a new frontier of robotic technology that they're bringing forward.
Yeah. So without further ado, let's jump to our conversation with Dainis Kruze from Aerones. Yeah, so a first line of business here, and we were just talking about this off camera, is I really want to hear about your experience with going through Y Combinator. So as a company, and all three of us are entrepreneurs in this conversation. Y Combinator is a very widely regarded startup incubator. So can you tell us a little bit about how your company got started, with you and your co-founder, and how you've gotten to, we're going to go all the way through your story in general, but tell us about the origins of Aerones.
Yeah, so me and Dainis, we know each other since we were 18. So we were studying together physics and mathematics, computer science. And that's actually where we met and where we built our first startup. We built GPS devices and the platform. We put the GPS devices on the vehicles, so the owners of the vehicles could see where their vehicles are, like for the companies, basically business to business. So this is how we started, and that company has actually grown to several other projects, IoT projects. It's called Intelligent Systems. It's Latvian company. So and like 5 years ago, Dainis exited the company, and like a year later came back and said, "Hey, I have a new great idea. Let's build a heavy lift drones. There are a lot of helicopters, there are planes, there are a lot of small drones, but nothing in between. Let's build heavy lift drones which can do some kind of a job." So it kind of started as a passion, and kind of we didn't have like the nice business stories where you see the problem and then you start to build the solution. We started to build these drones, but during the development, and we did a lot of different kind of trials, like human rescue, firefighting drones, and different kind of interesting stuff with a drone which could lift 440 pounds, actually 200 kilos. So, but we understood that we are kind of a little bit too early in the market, and that kind of business needs quite a lot of money for development. It's tough. And we thought that, that we build this firefighting drone, and we understood that it's not, time to market is going to be long. So we figure out that, hey, let's clean turbines with a drone. We heard in one exhibition that it's done by helicopters and etc. So we trialed it out, and we understood that, that it's possible. And more of that nobody cares what's happening in the wind park, right? It's not in the middle of the city or whatsoever. So we started to build this drone for wind turbine cleaning or de-icing. And we had the problems that the drone, I can actually share the screen, like how the drone looked like.
Yes.
Mm-hmm. And the video. Yeah, so this was the first video of the drone, which was de-icing the turbine. And we got quite huge traction of that. The industry, mainly it was like, it was something entirely new, something crazy. And But when we started to build this drone to do the job, here you can see these 3 legs, right? We understood that we needed to come to the blade quite close, and we wanted to do more of the things, not only the cleaning, but also, for example, conductivity tests, lighting protection system tests, painting, and etc. But we understood that the swinging in the air for the drone was still happening. So we created these 3 winches, which were holding the drone steady in the air, in the position. And then we just understood, damn, we don't need the drone. We just need another winch over the turbine. And it's much better solution. and that was kind of a moment when you need to decide if you are, if you stay focused on your technology or you stay focused on the problem. So we had found the problem, and we had found the solution. So we had to kind of go away from the drone technology, and we needed to start to build the robotic technology. So that's actually kind of the turning point in our mindsets, in our business, in everything. And I think that we did the right choice. We've managed in these 2 years when this happened, before 2 years ago. I think we've done a great job, and we've built a realistic robotic system which is actually capable of doing job, and we proved that.
And that's part of the Y Combinator thought process, right? Is to identify the problem, not the solution, and to work the problem first, and then find the solution, which is a sellable product. And I think you've done a very good job of that. And did the Y Combinator help focus you on that aspect of it?
Y Combinator, they don't come. They're not coming and telling you where, what, how you should do, like in your technology, like how to. But what they definitely did with us was they taught us, and like every second week you go to your mentors, and they're saying, like, stay focused on the where's the money, where's the business, how will you finance this, because any company can't be just fun, can't be just like what you like to build. It has to also generate some revenue, so you are interesting for the investors and etc. And yes, and you need the problem which you are solving. You can't have heavy lift drone which is could do everything, but yeah. So we didn't find a proper market fit for our drone, but we found a proper problem which we knew how to solve, and that's one of the biggest things which Y Combinator taught us, like stay focused on the problem.
And I think you've done a remarkable job of switching gears in some sense, because the technology shift from sort of drone and programming of drones and such a large drone, and then to switch over to essentially a rope-based system, that technology leap is big, and you seem to make that transition relatively smoothly. Obviously, you must have talented people on your staff to do that. But was that sort of transition happened in the Y Combinator when you said, okay, these drones won't solve that problem, we need to get to a different solution because we know what the problem is, but our solution right now is really not adaptable to that particular problem? Is that where that occurred?
Later, when we already graduated the Y Combinator, I would say that we found the solution how to solve it. Without the drone, we basically found that the drone is not the best solution, but this robotic system is best solution. We already had the problem. Like during the Y Combinator, they also said, like, okay, are you doing firefighting? Are you doing turbine cleaning? Or what? What's your drone going to do? Like, pick one, not all of them. Pick one, just one.
Right.
That was done by the Y Combinator, yes. And then, yes, after the Y Combinator, like half a year later, we just found, when we were desperately building this drone to clean the turbine, we were trialing that out, and we understood that it's not kind of working well. And then we found out this other solution.
That is probably one of the most difficult engineering hurdles to overcome, because you do get in love with your product.
Yes.
And you do not want to change it, because you know what it can do, and you feel like you have, and you have this amount of time and effort and love and all these relationships that revolve around this particular product. And you have to say to yourself, today is a day we stop and we're going to let all that go and all that's in the past. And now we're going to have to refigure our company to go towards a different product. That is such a hard transition. And so many companies, relatively few, I bet you it's less than 5%, can actually make that jump. So to say that you made that jump, and I think you have made that jump brilliantly, I think that you made that jump, it says a lot about your talent stack and the staff that you have to do that, because that is really difficult to do. It just is.
It's not an easy decision. It was tough decision, like how to explain to your investors, how to explain to the customers. Right. Like you were talking about the drones, and now you're talking the robotics, and you haven't actually tested it yet. And but you need to convince everyone that that's the way to go. The previous thing is not working. And so that's that was the situation, and tough decisions needed to be made, and we did that.
Did all your investors stay through that transition?
Yes.
Oh, they did?
Yes.
Wow.
Yes.
You have a great bunch of investors, because that's a very difficult, because the investors treat a company like yours, like one of their children on some level.
Yeah.
And it's hard to change that child out and put that one child aside or bring in a new child. It's hard to do. That's amazing. Yeah. That is really amazing.
Yeah.
Wow.
Thanks God, it all actually went through kind of. I wouldn't say hard. It was hard decisions, but when we started to explain to investors, when we started to explain to the customers, it actually went through quite smoothly. There was no big challenge of explaining. If they believe in you, they believe in you. That's also one of the things which was taught by the Y Combinator, that actually the company is the people inside. What can you actually do? What is your team? Can they deliver? And in our case, yes, we had great staff of mechanical engineering, of electronic engineering, of software engineers. So we were able to do that, and we did that.
So I want to jump to the beginning of Y Combinator. So obviously, lots of companies want to go through that process. How did you guys get that started, and how did you get accepted into the program?
Well, they actually invited us. So we didn't know anything about Y Combinator when they invited us. And because of this big buzz on this heavy lift drone and firefighting drone, they actually invited us because of the firefighting drone. And also only when we got to the first interview and we spoke with them, they also said, like, okay, the drone could do the firefighting and also the cleaning of the turbines. Like, actually, great idea. Like, okay, let's try that. And yeah, we are, I believe, one of the very few which were invited. I honestly believe that.
Oh yeah, very few are invited.
And did you have to change your business in any way? Did you have to sort of conform to fit their mold, or they're just like, come along as you are?
Come along as you are. I haven't spoken to them or they haven't said to us like how they have done the decision on us, particularly on us. But I believe that they just believe that we can do that. That the ideas are good, and if we've managed to get where we were, they believe that we will do something bigger as well.
Yeah, I mean, the drone technology, just as a whole for the wind turbine industry, just is like a no-brainer, right? I mean, and obviously the robotics is just an extension of that, but sending people up on ropes is terrifying, right? And it's time-consuming and it's expensive, and so like the drone, I could see anyone, and obviously those people who are funding startups and these investors are very forward-looking, right? They see a drone fighting a fire, they're like, yep, that makes a lot of sense. Let's not send people into that burning building. Like, that's the future, so that makes sense to me for sure. And I'm sure, Alan, like we're both trying to look and highlight new technology here on the show. And that's just like one of the most obvious ones. Like, send drones up and send robots up. Don't send human beings up.
There's one thing which is in all health and safety regulations and requirements that don't work at height if there is particular alternative. We just enable for the technicians to do the job much faster. and that's it. And you don't have to hang in the ropes, and to sometimes to perform as easy task as to touch something with something. So that could be done by is now being done by the robot.
Yeah, I mean, even little tasks like cleaning your gutters on your house 15 feet off the ground, people get killed every year doing that, right? I mean, like all these things, the applications just seem huge. So yeah, that seems like a no-brainer. So what were some of the big things that you took away from the Y Combinator program that are still in place and helping your business today?
Particularly, I think it's the mindset of how to think in larger scale, how to think on. Basically, you meet so many people, and you meet in person with all of those great founders which have graduated the Y Combinator, and their story, telling their story, which are not white and shiny, as in the end everybody thinks he just got lucky, and that's why he's a billionaire or millionaire or whatsoever. It's not actually true. Most of them, I actually didn't hear any of the stories from those guys from which were doing the lectures. That I didn't hear any easy, story how they built their businesses. So, and when you hear those stories, and when you meet them in you can see them in person, and for me, it changed the mindset that hey, it's not actually, they are not super humans or whatsoever, and that's, I think, most important thing, at least for me, and I think also for all of our company, that we are building it from moment when we started to work when we started the Y Combinator and when we ended. We are always thinking just in big scale, not in a small business scale, and etc. And it actually helps. It sounds stupid, I believe, but it helps.
Well, I'm just going to relate to, because Dainis, you basically said what Steve Jobs said probably 20 plus years ago now, which essentially is this, that when you look at the people who have founded companies and made fortunes, they're still real people, and they have just they've had a skill set and a sort of drive to get them somewhere, but they're not really any different than you or me. The fact of the matter is that normal people can do amazing things, and I think your company is one of those amazing companies that are doing amazing things, and it's leveraging the skill set that you have to and the mindset. I think you're right. It's sort of a mindset to ignore all the sort of the bad stuff and focus on the things that are going to move you forward. That is so hard to instill into new corporations and new companies, because you should kind of get fixated on some of the minutia instead of focusing on what needs to be done ahead of time. And you have done that. And I think hopefully the Y Combinator is part of that, but I also think part of that maybe just your personality type, that, hey, I can let that stuff go. It's hard to do. It's really hard to do. So I applaud you for being able to do that, because it's really difficult.
One more thing is that also, when you go through the Y Combinator, you see that all of those guys have built their companies in hard work. It's not an easy path, and we hear the good stories about big companies and so on. Those are one of I don't know, 1,000 or 1,000,000, which succeed. There are so many companies which doesn't. And that you need to stay focused. You need to work hard to actually build a company if you want to build a global and big and grateful company and great company.
Oh, sure.
So that's also one of the things that to understand. It doesn't come easy, but it's possible.
Well, let's jump forward to today. So tell us about Aerones today. What do you guys offer? Where is your technology gone? And what's sort of like your value proposition to a wind farm site owner operator?
We have kind of two things in our technology, like in what we offer. One is the delivery system, which is basically, this 4 winches which are delivering the platform. And the second part are those robotic arms. So right now we have fully developed these winch systems which are standing on the grounds and the middle where you exchange these arms. So the first service, which is like the most developed and basically where we already start to scale in amount of the robots, is lightning protection system test. So, but we have trialed out so many other robotic arms, like where we are just continuing to develop more and more arms which are doing particular different kind of tasks. So the delivery system, like these winch systems, allows us to move very fast and be wherever on the blade we want in matter of minutes, and touch it, scrub it, sand it, grind it, poke it, or whatsoever. So that's like the biggest thing we've kind of developed in the last 2 years, where we are confident that it works, that it's already scalable. And the lightning protection system test, this robotic arm. And during this season, this is basically the first season where we went out in the market, the services for money. And we succeeded with these lightning protection system tests. We've done more than 50 projects with players like Vestas, GE, Siemens Gamesa, NL, VPD, EDF, and etc. But we've trialed out also a lot of other robotic arms, like sanding, grinding, painting, filler apply, profiling, cleaning of the blades, and etc., where you will see a lot of new arms which are being developed right now and which are being prepared for the next season in basically March, April.
So to think of your technology, then it's really a two separate pieces almost. You have the rope system and all the controls that they're involved in that system, and then the robotic, the platform. I would call it the platform.
Yes.
The platform where you can interchange pieces on the platform to do like the lightning LPS measurements, and then the leading edge erosion repairs and those kind of things. Those technologies are somewhat, I think you're thinking of them as somewhat separate because they are interchangeable pieces, and that's a unique thing about your system. I think that makes it so adaptable to the problem that an asset owner may have, is that it's just not one thing that's trying to do everything. They're interchangeable pieces to address the problem they're having, which is the brilliant part of the way it's set up. It's modular for a reason.
Yeah, exactly. That was the goal from the very beginning, and that's the goal. What we want to achieve is that we create a platform which is capable of doing like all of the necessary things for the preventive blade maintenance in the future.
Yeah. And so you've measured in terms of the lightning protection system. I'm going to veer off into lightning here because that's our expertise. But you actually do a couple of different aspects involved with lightning protection systems. One, you can actually do the resistance measurements, which are really, really needed in the industry because it gives you a sort of a health measure on how well the LPS system is doing. The second little piece that you can do is you can determine if there's the little spark gaps that may be in the system, if those are working correctly.
Yes.
With your little voltage breakdown system, which is brilliant, by the way. But then you could also, because you are on the blade, you can actually do some inspections on the blade, like around the receptor where there may be some heat damage or some burning damage, or you can look at leading edge erosion because you're right there at that time. You can actually investigate what happens on the blade from terms of lightning damage. And then this newest little robot, which I think is just fascinating to me, is the robot that actually goes inside of the blade. You can actually take pictures inside the blade, because the lightning damage you see on the outside is usually minor compared to the lightning damage you see inside. So you have this sort of lightning protection robot suite of technologies there that is inclusive of pretty much every aspect of the lightning damage or lightning protection world. How did you come about doing all of that? How did you find that as something to even investigate? What drove that?
Basically, stick to the problem. So we know that the lightning damages causes like a lot of problems on the blades, right? So, and we understood that also, like when you start to ask questions to the customers, and when you start to ask questions to yourself, why you are building this, what's the value proposition for the customer? Is it enough just to measure that the lightning protection system is working or not? Or if it's not working, then do you want to troubleshoot? Actually, would you like to actually troubleshoot to understand why it's not working? Where is the problem? And when you potentially know where is the problem, would you like to investigate even deeper, and understand what's the problem, what's the cause of the problem? So yes, so therefore we understood that there are also there are a lot of companies which are doing visual inspections, and we have the difference that we can actually touch the things, right? And which you can't do with the drones and etc. And which are brilliant solutions. Like the drones can do the visual inspections, or from the ground, or with the drones in the air. And then we dive deeper when you see the problems, like how to investigate. Also, all of our future developments, like ultrasound crack inspections, active thermal inspections, internal inspections from inside of the blade, and etc., is like the next step after the visual inspection. And of course, in visual inspection, you can't see if the lightning protection system is or is not working. And what also on our past, we have now worked on basically almost all manufactured turbines available in the market, and we already start to get sense of what kind of problems each of the manufacturers have in their blades, in their turbines. So we can start to develop more things for each of the customer line or manufacturer line of the turbines, like how to actually navigate if there is lightning protection systems, for example, not working, how to understand where is the problem. Like, is it in the root of the blade, or is it somewhere in where you can access from inside, or is it somewhere in the tip of the blade where you need to access and repair it from the basket, from outside of the blade? So these are the things on which we are trying to get. As if we do the inspection, the next task for the next guys who are coming and repairing that, they know particularly what to do, where, what to do, and so on. So we want to be this one-stop shop, which is actually not only just saying, "Hey, it's not working," and it's not our problem.
Sure.
Yeah.
So we want to already give some suggestions and be experts in the industry where, what, how, why should be done next.
So you've now measured roughly how many blades for LPS resistance?
Say a lot more than 1,000 blades and more than 5,000 receptors for sure.
Wow. Okay.
It's like some of the turbines some of the blades have only 2 receptors. Some of them have 18 receptors per blade.
That's right. That's right.
And this is also how you can calculate what's the potential of the problem and so on. But yes, and we've learned a lot. We've learned a lot during this year while developing, also getting the information how these LPS systems are built in different kind of manufacturers of different kind of manufacturers and so on.
So you've now measured a substantial number of blades and LPS systems. And I saw some data recently from your company that had some rough numbers on the number of blades that have LPS resistance issues.
Yes.
And if you want to explain that, because it's a substantial number, it's a lot.
We're actually more than surprised as well, because when we started to work in the LPS measurements, most of the companies, also our customers, thought that it's not such a big problem. Actually, the LPS is not a big problem. And when you start to measure, then you see that it's actually a big problem. and what we saw basically, and we still see, is many of the inspections of LPS systems are not done correctly, because it's kind of they just give some equipment to some rope technicians that they're saying just put one end here and one end here and read the data and just write it somewhere and that's it. Mm-hmm. Without understanding actually properly what is he doing there, why, and etc. So in our case, we as I said, we've dived a lot deeper than just resistance measurements. And what we've seen that it's in most of the cases it's poor job. It's nobody has actually measured the lightning protection systems properly. The other thing is in some of the cases, they haven't tested them at all because they think that it's all good, because they just think that it's all good. And when you measure and when you show to them the statistics, it's like, but how? It shouldn't be like this.
Right.
And yeah, so the statistics are quite, so basically, like I'm just seeing the latest statistics which we have. It's like 14% of the receptors have open circuit, like 1/4.
Wow.
And only 1% has, for example, this increased resistance. Like, so the open circuit is actually a big problem. So it means that when the lightning hits those receptors, you will probably have sparks left and right. Either it's because of broken wires inside, either it's because of oxidation in wires, and etc. But it's a bigger risk to get also pinholes, broken blades, cracks on the blades, and etc.
Right.
So I believe that next year we will have even a better information on this, because we will try to combine our data of LPS problems together with visual inspections. So we will see the statistics, like if the blade had, for example, open circuit on some or on all of the blade or some of the receptors. Do they have more pinholes or cracks in the blades because of the lightning,
right,
etc.
Right.
So I kind of have a sense that we will have like our theory will be right, that it will be quite.
There will be a good correlation between that data, between the lightning receptor resistance and the damage to the blade. I think those are going to correlate very well.
Yeah.
They may not be exactly 100%, but it's going to be close, because what you're saying is essentially, if I look at 2 wind turbines and there's a total of 6 blades, one of those blades has an LPS problem.
Yeah.
Roughly.
Yeah.
Right? So if I have 100 blades or 100 turbines, there's a lot of blades on that site that have an LPS issue, and it tends to be generically broken things internally, which are really significant, because if what's happening internally to that blade, if you really have an open circuit, you have a broken connection, there will be a lightning arc inside of your blade, which is really damaging to that blade. So you're right, you're going to see some structural damage to the blade in places that you don't want it, that can later on cause more, maybe even a catastrophic failure for that blade, because something as simple as a broken wire can lead to that. And I think a lot of operators and owners and asset owners look at the LPS system as essentially a big copper wire and a couple of little metal connections. How complicated could it be? But I think your finding is that it is a lot more complicated than we have assumed for a long period of time. And until we've had that data, we've all assumed it's always been fine. And so a lot of these lightning issues we're seeing in the field don't make any sense. And maybe now they'll start to correlate to making sense, because if you're seeing roughly 15% of the LPS system have an open circuit, that's a significant problem in the industry.
And it comes with the ages, like the older the turbines, the bigger the problems are.
Sure.
And yes, exactly as you said, like everyone thinks, like not everyone, but most of the customers think that it's just a copper wire inside. And even if the lightning will strike, even if there will be some broken wires or oxidations there, it will jump through and go to the ground. Is actually not the way how it works in the life, because the lightning strike is such a huge amount of energy. You can actually, you can't, like physically, people cannot understand the potential, how much it actually is.
Yes, that's true.
Yes, to actually to maintain that, it's not that easy.
No, it's not, and it's hard to correlate the lightning, the potential lightning damage, because it's so hard to see, because when everything's working correctly, and I think this is where a lot of asset managers have issues. When it works correctly, you have a relatively small copper wire that's carrying all this energy, and it's clean, it's smooth, you just don't have any issues. But as soon as you break that connection, now you have almost cataclysmic type levels of explosions happening internally to your blade. Exactly. It's like it's setting off a small set of dynamite inside of this blade. And so it goes from essentially no problem to significant problem immediately. And it's hard to, everything else about a wind turbine is gradual. Bearing wearing out is gradual. Fatigue damage is gradual. Any sort of electrical failure tends to be somewhat gradual. Mechanical failure tends to be gradual. This is going from 0 to 100% almost immediately.
Yeah. Mm-hmm.
And I think this is where your data is really, really, really important for the industry to get a handle on, is to understand that these type of situations need to get addressed quickly and immediately, that you're really putting your site at risk if you don't look at it.
But I think that the industry is growing. Like also the visual inspection companies, which are doing actually a great job. They are educating the customers on how big the problems actually are, how many of the problems they actually have, all of the statistics in the platforms of the cracks and etc. Start to show them the realistic numbers of what's actually happening. And I believe that is going to open for us as well, like a lot wider market and bigger understanding from the customers.
Right. Well, Dainis, part of you said roughly 1% of the measurements you're making are just essentially resistance measurements, where the resistance is high because they probably have some sort of corrosion between the connections. And you've tried to address that in really two separate ways. One, you're measuring it, so you have a way to identify it. But if left unattended and a lightning strike does happen, what happens in those joints is there's just a big explosion of sparks and heat, and all these bad things start to happen. You have addressed it in a way to correct it on site. And would you like to explain how that system works?
Basically, what we do, we just send in, we create like a full circuit of the system, and we send in 1,000 volts. And like 1 ampere, we start with 1 ampere and then we raise. But basically, in all of the projects, it was between 1 and 3 amperes. So what we actually do, we kind of the electricity starts to flow through the point where the oxidation has happened, and it starts that point. It's like it starts to shake, and it removes the oxidation. It kind of shakes against each other, and it removes the oxidation. We call it the welding process, but it's actually not welding.
Yes. It's sort of a friction process.
Which is removing the oxidation, and the good connection is restored. So so you don't have to open the blade. You don't have to do thousands of euros expensive repair or dollars expensive repair with many days of downtime of the turbine. It's done in a few hours and costs a fraction of what you would pay for opening the blade and etc. So that's also one of the new things which we have developed, and we see good results with that.
So that's sort of why Combinator thought process is, hey, there's a problem, let's try to address it.
Yeah.
There's a marketplace, there's a problem, we're going to try to address it, because that also fits into the other product, which is really sort of intuitive but hasn't been done, is to look at some of the turbines like Siemens or Gamesa has, in particular, these spark gaps that are built into the system to get from the blades to the hub to the nacelle, and you have really no way to determine how well those are working. For the most part, right? You have to get somebody physically up there to look at them, make sure they're clean, and make sure that they're the right distances and all those things. So it takes a person a long time to do that. But you've come up with a much more intuitive way to measure those gaps. And would you like to explain that, how you're doing that?
Basically, we create a artificial spark. The spark in the electricity line, it will always jump through the shortest gap. And so we create for the spark to jump 1 millimeter of air, you need 3 kilovolts. So basically, if you want to jump, and in most of these cases, these spark gaps are 4 centimeters, like it's almost something like 3 inch, 2.5 inch. So these 4 centimeters, it means that you need 40 multiplied by 3, 120 kilovolts to jump it through. So and this is what we can actually exactly give and see if it jumps through the spark gap or not, or we need a higher voltage to jump through it actually. So this is a perfect way how to actually test the spark gaps, sliding discs or brush connections, to actually see what voltage you need is it working by the manual or not?
That's right. Because it could be too low, which indicates you have a sneak electrical path through some piece of some component you don't want to be involved.
Exactly.
Or it can be too high, which can tell you the spark gap is not working correctly or the brush isn't working correctly. So it's bounded on either the high side or the low side. And unless you're in that right correct band, you will see damage of some sort on your wind turbine if you're not in that band.
Yeah, exactly. And
yeah, so it's very important, I think, to highlight that. So you are addressing so many different problems, and you have the technology right on site to identify them, but also to correct them, which a lot of times they don't. So just going out and having somebody on a rope do a resistance measurement, I agree with you, the technicians, it's a very difficult measurement to make. Let's just start there. So not having maybe the training or the technology to make those measurements on a rope is one thing. But even if they were to identify that there was an issue, they would have the ability to do nothing about it, right? They still got to bring a company like yours in to come to do the correction. So it makes a lot of sense to use your robot, to use your technology to, one, identify the issue, but two, to correct it on site quickly. And I think that's where the problem solving aspect comes in, is that there's just no way to beat that system. It's just brilliant on all levels.
And one more thing is that we have worked that out as like a step after step process where we can't do anything wrong. Everything is recorded with cameras and etc. So we can't do anything wrong, and it's and we can't just not do that. The process is so smooth and so fast that we can do much faster. And the process is worked out that we are definitely doing a proper job.
And this is where Dan always comes in and says, hey, what's the customer's point of view? What's the customer's thinking of this? One of the things that I think is interesting in what your technology is that the customer can actually see the video of you doing the measurements and see the video of you doing all the things on site. So you have a database. Now, and maybe you can explain to Dan and me how that data system works. How does your customers interface with all that data that you collect? What does that look like?
Now, basically a platform where you can actually see all of the measurements. Everything is digitally stored, so every measurement you can actually see the video of how it was taken, what was seen in the display in this Megger low ohm resistance meter, and what was seen in the cameras. If we will have any dispute with some customer, like he will ask, no, this measurement shouldn't be right, or it can't be truth, and etc., he can see the process all through in the cameras and digitally stored data. That's one of the beautiful things. And also we have high resolution videos, high resolution pictures of all of the receptors, where we not only that's actually one of the last week's things which we started to develop, and where we have already trialed out, was that you get not only the measurement, but also a picture of the receptor, and with description what we see in this receptor, as you said previously, about if the paint all around has bubbles and etc., or it's burned through, even if the measurements are right or correct, you can see that some problems still are there. So this is one of the things how we step next step further in our reporting to the customer. And yes, and from the January we will publish this our platform, where all of the data will be sent to the customers, not anymore like a report to the email, but basically the customers will be able to come into the portal. And more of that, what we offer is API, that if the customer is using some other portal, some other inspection platform, he doesn't want to use several of them, it's not a problem. We can just give the data to your platform. You can and you can use your preferred platform you like.
Wow. Okay, that's really interesting, because that is one of the issues that's going on. There's so many pieces of information, so many platforms that they're trying to condense them, right? And that's one of the issues we've seen lately. Yeah. There's so much information.
Yeah, and companies just want to be, at the end of the day, everyone's dug in and everyone understands the system that they have and they're all trained on it, and they don't want to just jump ship to a new platform every 6 months or a year. It's exhausting.
It's also that we are the strongest in this engineering of building robots and etc. There's plenty of players in the platform with the good platforms where we could just give the data in. And as you said, yes, the customer is already using something. To shift from one platform to another, it's not actually that easy task as it sounds. Mm-hmm. And therefore, we are offering this API just to get the data to any platform you want.
I want you to explain how you clean the drain holes, because I've watched some of your video on YouTube of how the drain holes are cleaned, and I think that's just the most fascinating thing. It seems relatively simple to do, but it's very complicated. It's difficult to do that.
Actually, we have another idea how to do that even better. So right now we're actually like the robot is grabbing the blade, and it has like a third hand with which it's cleaning out the drainage hole. But we have the idea, and we will trial it out in a few months, is that it will blow in or suck the air, so we actually know how good the drainage hole is actually working, like what the pressure we are building up. That will be one other probable solution for that. But otherwise, yes, we are cleaning the drainage hole under the exact angle, and we are already talking also to OEMs about if the drainage hole is clogged, the robot could just drill another hole, but in the particular place, right, and in particular angle, and it, as it, should be made, not just a hole somewhere.
Right. Mm-hmm. Right. Yeah. Well, because the other part of this whole system is Dan and I like to think 2-3 years down the line. So your technology is very applicable to doing a number of repairs, modifications to wind turbines, blades, and you also do things to the towers themselves. You can clean the towers off, which I think is brilliant. Okay, so part of that mix also now is that you also have the drone technology, which is doing scans, like a SkySpecs can do scans of blades very quickly. Boom, 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 boom. In a matter of minutes, they can have a wind turbine inspected, and they're off to the next wind turbine.
Yeah.
So in terms of, you fit into that ecostructure in the sense that there's inspections being done, they're identifying issues, and then you can come in and address that issue specifically quickly, and be relatively on site relatively quickly and get that repair made or get the receptors measured or whatever they need to go do. And so the whole world is getting faster. It's one of those things we've done a lot of technology with people on ropes, and you're right. If you don't have to work at height, don't. Mm. And so have you seen, what do you see as that sort of future now? Because everything is becoming more automated and better. There's better data, and the customers have more access to it at their fingertips immediately. Where does this all sort of get connected, and where is it going?
Yeah, I think the speed will be the key issue in the service of the wind industry. The turbines are becoming bigger, more effective. Now the downtime of the turbine costs more than in some cases in the labor and right, the job itself, right? And it's if we are calculating only the expense or the ungenerated electricity, but if we start to calculate in also all of the logistics, like to organize this, that you need to stop the turbine, it needs to be stopped, and etc. It's actually you lose quite a lot of money. The customers are losing quite a lot of money on that. Right. I believe that, yes, we are talking also with SkySpecs, for example, that while we are doing conductivity, their drone is doing the visual inspection. So how we could combine our services, like the inspection companies, drone inspection companies, and our company, like how we could work together, so we could bring together a bigger value to the customer. Less stoppings, faster job, right, and basically everybody happy. Safer and cheaper, I think win-win situation. Then you can afford to do that more frequent. You can afford to do that more frequent. You can I think one of the biggest issues in the industry right now is that all of the industry, like I can't say all, but most of the industry is working on corrective maintenance, not in
That's right.
predictive maintenance. So I think that
That's
the
right.
biggest shift in the industry will be when the companies like will start to switch from corrective maintenance to preventive maintenance. Like for example, like when we go to the customers and we are saying, hey, we can repair the leading edge, everybody's saying like, with the robot, you will not be able to repair the laminate, do the structural repair. And we are saying, this is because you're doing it too late. You should repair the leading edge when only the leading edge protection material has been, is gone because of the erosion, or the filler starts to erode. So let's do the renewal of the leading edge once in 3 years in less than 5 hours, and forget about structural repairs, which lasts for days. And that's also like for the most of the customers are, yeah, but we're not used to do that like that, and I think that will be also like one quite actually big jump in the industry, which will add some on all of the industry. For example, 7 additional % in because of the blades are clean, the blades leading edge is always intact, lighting protection is working, etc., etc. That's going to raise all industry, not by more turbines, but just by doing a better maintenance.
I totally agree with you. I think the industry is going to shift dramatically over the next couple of years because of the speeds that are involved, and that it opens up doors that we haven't thought of before, because it is a big ordeal to shut a turbine down, to get train people on it properly, to get everybody on and off safely, and then get everything started up again. It just takes a tremendous amount of effort to do that. But in terms of just the sort of the way the future growth is going, I've noticed that your robot system is available on different continents. Are you partnering with different companies like in Brazil and the United States to bring your technology across the whole span of the world?
Yeah, exactly what we do. We basically search for a local partner who wants to work with us. And so we work, basically, yeah, we are opening partnerships in lots of different countries. And basically, we deliver the robot with one technician who is teaching the local technicians to work with the robot. That's the idea of all of the systems, where we want it to be that it's as simple that we can teach you guys like in a week or two to actually operate it. So there. That's the point where it should be, and we are closing up on that, honestly.
Well, Dan, that sounds like something that's up your line of. We could train you how to work a robot on top of everything else you're doing. So it sounds like it is a technical job. I mean, it's probably a pretty paying job to do that, because it takes a certain skill set to do that. And I know we've seen and gotten a lot of inquiries. I know sort of SkySpecs has gotten the same sort of inquiries about. They want to have that technology on offshore on each platform. Is that where the future is, that you're going to have a robot system on each of these platforms, on each of these turbines, because they're 12 megawatt or 14 megawatt or 20 megawatt at some point, that it just makes sense to have that on site?
That's for sure, because already our robot is actually this remote control, and where the technician is controlling the robot, it's already built that we could actually control it from office. Of course, you need to go through the stages of development to actually start to do that remotely, not on site. But all of our development goes for that. We could actually leave the robot there and just connect to the robot when there is no wind, for example, and basically and do the job when it's best for the customer, not when we are there. You need to stop the turbine. So that's and for offshore, that's for sure. The cost of delivering the robot, to mount the robot on, then take it off, and et cetera, is just too expensive. Like eventually, the cost of the robot will be less than delivering it there, and exchanging maybe it once in a month, for example, like just to bring from one turbine to another. So yes, I think it's inevitable that these kind of robots will do the job like completely remotely, and a lot of things, like also, like, for example, for our robot, we're already working on that the robot is actually doing it itself, the job itself. It knows how to track and understand where the receptor is. It understands with what speed it needs to move, how to navigate there, how to do the measurement, and etc. That actually you don't need anyone to control the joysticks, basically the remote. So that's the next step as well.
Wow. Okay, that's fascinating. There's so much technology, and we haven't even touched upon the one issue that Dan has written some articles about, and we're talking about internally, which is the blade cleaning. That in terms of lightning protection, we've seen pictures from all across the world of really, really dirty blades, and that definitely affects a lightning protection system. It just defeats the point of a lightning protection system because the whole blade is conductive on some level. Can you explain how your system actually cleans the blades?
Cleanings in Costa Rica.
Oh wow!
Where the blades were actually dirty, not Europe's dirty or United States dirty. It's like we understood what dirty means. Can be done, like for the humans, it's like 9 days to clean one turbine.
Yikes!
And for the robot, we did in 3 days, like one blade per day. But you will understand, it's a game changer. Also, like aerodynamics. The dirt maybe is not affecting like 10 or 15% of aerodynamics of the turbine, but it's definitely affecting. There are so many wind tunnel experiments where in the universities where they have seen that even a slight dirtiness or erosion is affecting the airflow around the blade. But of course, it's hard to convince on this the customers because you can't see the SCADA data about how much of electricity has been made in what kind of wind speed is not 100% accurate because the area where the turbine is receiving the wind is a lot larger than where you have this 1 meter, which is this measurement tool, which is measuring what's average wind speed in on that turbine. So it's not completely accurate, and so you can't measure that exactly how much you are losing because of the dirt or erosion of the blades.
Wow.
This is dirtiness.
Yes.
And basically to scrub that by hand on, I don't remember, this was like 50 meter or 60 meter long blade, but basically to scrub that by hand, it's just like it's a lot. You need a lot of time.
Do you know what that's from? Is that from? I know some places of the world they like to burn off the fields before they replant, and that's one of the. There's a lot of smoke in the air, and
this is
sort of pollution in the air.
This is volcano.
Oh, it's volcano.
Yeah, volcano, and basically the algae, which is like the debris is sitting down on the blade, and the algae starts to live there,
to grow.
Yeah, and so you need to clean them once in a year. Of course, this is the worst case scenario, of course, kind of. But we've cleaned, like, for example, European blades. If we are cleaning European blades in Europe, it's like 1 turbine a day, like 3 blades per day. Where again, for rope technicians, it's 3 to 6 days to clean them. And this is why the industry is not doing that, because it's just it costs a lot of money. It's a lot of downtime. It's a lot of days to work on, and this is why it's not done.
Yeah, and then they just say, "Oh, it's probably not that big a deal. 9 days of downtime, it's probably not a big deal." But
exactly.
Well, I know, and Alan, you had a talk with, I think it was Nicholas Guadern from Power Curve, who said that there was a blade that had just caked on dirt to the leading edge that caused it actually to stall. Like the stall speed was pretty. There was a very small window in the manufacture of this one blade, and the caked on dirt caused it to hit its stall point, and it just stopped operating.
Yeah, it just won't run. Right.
Also, icing is happening more if there is, for the humidity where to grow, like where to stay for the humidity, and therefore the icing is happening a lot more if the blades are dirty.
Sure.
and so on. So yes, so now we are working on the improvements of also this system where we could clean in one day one blade in Costa Rica like that, dirtiness blades. And next year the process will be already like at least 2 times faster. So one turbine, 1.5 days, and for Europe like definitely in 1 day. Fast, safe process of cleaning of the blades.
There's your Y Combinator aspect. See the problem, fix the problem.
Yeah.
Get to the problem, right? And as you get further and further away from home, you're going to see just a wider variety of issues that need to be addressed. So it's going to, the next couple of years are going to be very interesting for you for sure. Those problems are going to get very complicated.
Yeah, exactly. And the educational process of the customers, that it's actually necessary, that it's actually like, hey, we are not doing that. Why should we do now? And then you need to convince and find the arguments why they should do that actually.
Yeah, I bet the technology changes so fast. 6 months ago, this didn't exist, and now it does. And it just human nature is to process, especially engineers. Engineers process things very slowly because they want to be safe. So it takes a while for adaptation. But I think in your particular case, because you're addressing other issues, safety issues, speed issues, downtime issues, that it makes the engineering part of it a little bit easier to swallow, which is, hey, they can just do it faster. And they're doing it just as well, and maybe providing me more data than I would have otherwise. So there's more pluses than there are minuses. So the adaptation speed for your particular projects are actually going to go faster than they would for some others, I think. It's a technology thing. And it's I'm going to keep saying this word, it's brilliant. Every time I watch a video of yours,
thank you.
On YouTube, I think, wow, that is amazing. It's just amazing. So our hats off to your technology and your company. It's just amazing to watch.
Thank you.
So as we start to wrap up here, how can other companies follow up with you? Where are you guys going in the near future? Do you have any new advances that you're really excited about that you're maybe going to be dripping out, or maybe we can look forward to in the next year?
Yeah, definitely. I think one of the killers will be the leading edge repair. That's one of the things which we will start to trial out next year. We've done already the first trials, like only with sanding and grinding with our robot. The process of average 9 days repair of leading edge and pinholes and etc. for the rope technicians was accelerated by 2 to 3 days on per turbine, like just sanding and grinding of the surface of the leading edge. Because we just do that in like 10 minutes per blade with the robot, rather than 1 day for the rope technician with hand.
Sure.
3M tape removal, again, big issue in industry is that you need to remove the 3M tape and you just lose days to remove that by hand.
It's tough.
Yeah.
Yes.
And now it's going to be possible in few hours. And yes, and those things which we are developing on NDT tests, like what we see the problem that, yes, there's a crack, but what's actually happening? Like, is it just what you see from outside? Is it larger actually or not? All of the wrinkle issue on the blades also needs to be addressed. So yes, stay tuned. We will have a lot of new things next year, and also in the middle of next year, we will trial out our technology not in onshore but in offshore. Like, we are bringing our technology to the offshore. So that's also is going to be, I think, a huge jump in our technology and for the whole wind industry, I guess.
Yeah, I mean, offshore is such a tough problem to solve. Like, you don't want to be sending people out to these inhospitable ocean environments, and you certainly don't want them up at height, with waves, and it's crazy. It's such a terrifying experience, I'm sure, to be a technician out there. Hats off to them, but yeah, I'm sure, like you said, that's just a huge growth market for you, just trying to simplify that process. Mm-hmm. Well, thank you so much for coming on the show. This was a really fascinating conversation. I'm sure we could have gone on for another hour. Yes. And maybe we'll have to have you back on in another year to see what's changed. But we really appreciate your time. This is exciting stuff that you guys are doing over at Aerones.
Yeah, guys, for having me on the show. And I can't wait to see it live.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.